So here we have three outcomes, 0, 1, and 2. So here is the set A, B, and C. So what's the probability of A or B? So that's going to be the probability of A or the probability of B. No overlap. So what's the probability of C? Because I'm just given those two. So that means I'm going to have the probability of all of it, right? The whole sum. The probability of the whole sample space. Subtract off the probability of A or B. So that's 1 minus the 0.7. So that gives me 0.3. All right, how about the probability of A or C? They are disjoint, right? Nothing in common, so that's 0.7. Probability of A complement is 1 minus the probability of A, so that's 1 minus 0.4, so that's 0.6. So I want to be careful in dealing with these complements and do De Morgan. So this is A union B complement. So that's the same thing as saying 1 minus probability of A union B. So that's 1 minus 0.7 or 0.3. This one here, probability of A intersect B complement. That's the same thing as saying, oh, wait a second, what's A intersect B? A intersect B is 0. It's the null set. So what's the complement of the null set? Well, that's the whole sample space. And what's the probability of the whole sample space? Just 1. All right, so here's a new problem I tossed in just for fun. So suppose we have a fair coin that's tossed 3 times. So let A be the event that a head appears on the first time, and B be the event that I have an even number of heads. So let's write out what A and B can be. So if you want, you can turn the video off and try to figure it out. But if I want a head on the first time, I have head, 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 or head, head, tail, or head, tail, head, or head, tail, tail. Okay, so those are all the different options. So then part event of B is there's an even number of heads. So I'll put the 2 heads first, or, whoops, I'll put the, I'm kind of trying to stay organized so I don't keep a pattern going. Head, tail, head, or tail, head, head, or remember 0 is an even number, so tail, tail, tail. All right, so probability of A would be 4 out of 8, and probability of B would be, oh, and how do I get 8? Oh, how do I get 8? Because if I'm tossing it 3 times, each of them has 2 options, so 2 cubed, right? So I've got 4 in this event A over the total number 8, and then probability of B would be 4 over the total number of 8. All right, so let's do this. So this would be the same thing as saying, right, probability of A given B is happening is probability of A and B over the probability of B. So that's going to be the 2 out of the 8. Probability of A and B is happening, right? If A and B is happening, that means I've got an overlap. Oh, I forgot to talk about that. Do I have an overlap? What do I have in common between these two? So I've got this, and I've got this, right? Those 2. So 2 out of the 8 over the probability of B, which is 1/2. And so that gives me 2 out of it, 1/4, so that gives me a 1/2, right? All right, so same thing for this one. Probability of B given A is probability of A and B over probability of A. So that's 2 out of 8 over 1/2, so that turns out to be the same. All right, let's fit one more in here. So if I pick pairs of numbers, so just picking pairs of numbers, so I'm going to pick the ones that will work to be sum of 15. So I've got 3 and 12, 4 and 11, right? 5 and 10, and then 6 and 9, and 7 and 8. 1, 2, 3, 4, 5 pairs that give me a sum of 15. So if I pick 6 integers, if I choose 6, then I'll have at least 1 pair. Because oops, because if I choose 5, worst case scenario, I choose 1, 2, 3, 4, 5. The next number I choose, 6, will give me a pair.